Hi everyone. When we do conversions in the metric system, we usually will just move the decimal point around. But if we're trying to work with the imperial system of measurements, we're not going to be able to do that. So we're going to need another method. So that's where this method comes in. We're going to take a look at unit conversions using proportions. Before we get going with our first problem, let's take a look at the basic format for setting up a proportion. So here's our general format. Now on the left side, this is what we're going to be calling the problem ratio. And if you look on top here, what we have is what we're trying to find, the x, and the units that we're trying to find that in. On the bottom, whatever the given amount is, and that'll come with some units. On the right-hand side, we're going to have what's known as the known ratio, or the conversion factor. And one of the things that you'll see about this is the units have to match from the left side to the right side. And so if we use units of A on top, then we're going to have units of A on the top for both sides. And you'll notice that the bottoms have the same units. You have unit of B on both sides. Let's take a look at a really simple example. If we had to convert from 2 feet into inches, our conversion might look something like this. So notice on the problem ratio side, I want to know the number of inches, so we put an X there since I don't know it. But we were given 2 feet. So here's my problem ratio then. I have X inches over 2 feet. On the other side, on the right-hand side, we have the known ratio. Well, we do know that 12 inches is equal to 1 foot. And so I've set the top and bottom equal to each other. And I've also set the units so that they're matching up. I have inches on the right on the top, inches on the left on the top. Feet on the bottom on the right-hand side, feet on the bottom on the left-hand side. So let me give a quick overview. When you set up your proportion, it's going to have 2 ratios or fractions. One of the ratios is going to be your known ratio, and it's just going to be a proportion that you know to be true. There are 12 inches in 1 foot. On the other side, you're going to have your problem ratio. Your problem ratio has your unknown and your given amount in it, and the units are set up in the exact same locations. Let's try an example from scratch. Here we're going to convert from 24 inches into centimeters. Now I can already get a sense of about what the answer is going to be because I know that 24 inches is about 2 feet, and a yard and a meter are very, very similar to each other. And so since I have about 2/3 of a yard, I'm going to have about 2/3 of a meter. And so I'm expecting an answer somewhere around 65 centimeters. Let's do the work and find out if my prediction was correct. First thing I'm going to do is I'm going to start to set up the skeleton structure for my proportion just by drawing 2 lines that will represent my fractions. So on the left side, I'm going to have that be my problem side, and I don't know the centimeters, so I'm just going to put X centimeters. I do have 24 inches as my given information, and I'll write that in. So I've just made a fraction out of my known and unknown. You could put the X on the bottom, you could put the X on the top. It doesn't really matter, just make a fraction out of the known and unknown. Now what's the relationship between centimeters and inches? Well, it turns out that 1 inch is equal to 2.54 centimeters. So I'm going to fill that information onto the known side, and I'm just going to match up the units. Since the centimeters were used on top on the left, I'm going to use centimeters on top on the right-hand side. So I'll put in the 2.54 centimeters on the top and then the 1 inch on the bottom. To finish solving this problem, we're going to cross multiply and divide. What I normally do is just start with the number that you started with, which is the 24 inches. And then just draw a long line for the diagonal, and then divide by whatever is on the other diagonal. So we'd have 24 times 2.54 divided by whatever is on the other diagonal, and that comes out to be equal to 60.96 centimeters. The units won't be hard to find because you already have specified what units you had with X, and so you're just copying those units. We had a prediction before that it was going to be somewhere around 66. It's not too far off, it's about 61, and so I feel pretty comfortable that I probably have the answer correct because my prediction was very close. And let's just take a look at the more formal way to go about finishing off this problem instead of that little fish symbol that I drew. The more formal way is you're just going to set the two diagonals equal to each other. So you'd have 24 times 2.54 is equal to x times 1. And then you isolate x and get it all by itself by dividing by whatever x is multiplied by. But since it's just 1, it's just going to kind of disappear. And so you just have to do 24 times 2.54, and that gives you your answer of 60.96. Let's try one more example to make sure that we have this down. So imagine that you wanted to find out how many liters are in a 50-gallon trash barrel. So first thing we're going to do is we're going to start to set up the outline of our proportion just by trying to set up so that we have two fractions equal to each other. I don't know the liters. I'm going to put X liters, but I do know that they have 50 gallons. Just made a fraction out of my known and unknown. Now, what's the relationship between gallons and liters? Well, we can look this up. It's 3.785412. Liters is equal to 1 gallon. So that's going to be my conversion factor or my known ratio. And I just have to put those into the correct spots on the known side of my proportion. So let's put the 3.785412 liters on the top, and we'll put the 1 gallon on the bottom. Then the only thing we have to do to finish this off is we're just going to cross multiply and divide. My starting point was 50 gallons, so I just start there, and I multiply 50 times 3.785412, and then divide by 1 gallon, which you technically don't even need to do. Our final answer came out to be that X is equal to 189.2706 liters. So just under, a little bit under 200 liters. Before we finish up, let's just do a quick check to make sure that our answer makes sense. If you take a look on the right-hand side, what you can see is that the top is a little bit less than 4 times as big as the bottom. And so that means that on the left side, the answer should be a little bit less than 4 times as big as the bottom. So 4 times 50 would be about 200. So the answer to the top should be a little less than 200. And here's our answer down here, a little less than 200. So our answer does make sense. Let's review what we've learned in this video. When we do unit conversions, when we're not in the metric system, you're not allowed to just move the decimal point around. Now, one way to solve the problem is to set up a proportion. When we set up the proportion, you're going to have two fractions or two ratios set equal to each other. One of the ratios we can call the problem ratio, and it just has a ratio of the known to the unknown. So in one of the spots you need to put an X for the thing that you don't know, and the other spot you're going to put down whatever the given information is and make them into a fraction. The other side has to be a ratio that you know to be true. You have to have something where you know that the top and the bottom are definitely equal to each other. So this is going to be a conversion, something that you know is correct. And for these conversion factors that we find on the right-hand side, I would not expect people to memorize these. We can look them up in a table or look them up on the internet.